Okay, so this is homework 3. What we're doing here, so homework 3, we're adding and subtracting rational expressions where the denominators are not like. So remember, when we are adding and subtracting fractions that do not have a common denominator, you have to get one. So in this case here, we have 1/2 plus 1/3. We find the common denominator by finding the least common multiple of 2 and 3, which is 6. So then we make the denominators into 6 using multiplication. So for the first fraction, we multiply by 3, which would give us 3/6. The second fraction, we multiply by 2, which gives us 2/6. Then when we add the fractions, we're only adding the numerators. We leave the denominator the same. So part of adding and subtracting rational expressions is finding the GCF, or sorry, the LCD, which is, it can be a little tricky when you first start, and then once you get there, not too bad. Factor the denominators first. If they're already factored, then you go to the second step. You would write down the different factors, or just observe what they are. Then you're going to look at the numbers and then the variables, okay? So for the numbers, it's just the LCD. Why does it say 4, 5, and 6? That's throwing me off. 1, 2, and 3. Okay, so for the numbers, it's just the LCD. Okay, so if I look at these denominators, 15y squared and 7y, the first thing I'm going to look at is 15 and 7, and I'm going to find the LCD of 15 and 7. So I would want to think of multiples of 15, and then see if I can get them to 7, to divide into 7. So I've got 15, 30, 45, 60, 75, 90, maybe 90 would work. I think that is, nope, 105. Yeah. So really you could just multiply 7 and 15. There's nothing smaller there. So the LCD of 15 and 7 is going to be 105. Okay, and then when you're looking at the variables, what you want to look at is you want to look at the powers. So the power is going to be the greatest power. Okay, so here you have y squared and y. You want to use the greatest power, so you would use the y squared. Okay, and then if you have factored variables, like say x plus 1 or x minus 1, you would want one of each factor. Okay, so for variables with an exponent, the greatest power, numbers is the LCD, and then you would also want one of each factor. And then this is just when we're looking at denominators. So when I look at this next one, these are just factors. Okay, so this is one of each factor. So the LCD here would just be x plus 7, x minus 7, one of each factor. Okay, now let's say we added in, you had another one here that was like x minus 7 squared. You would take the greatest power of the factor, so the LCD here would be x plus 7, x minus 7 squared. All right, so let's do an example. We'll start with a simple one. So we have 4 over 6x plus 1 over 9x. Here's our steps. So if it's subtraction, we're going to distribute the minus sign to the second numerator. This is addition, so we're going to go to step 2. We're going to find the LCD. So for here, you want the least common multiple of 6 and 9. What would that be? Yeah, 18. And then for the variables, you want the greatest power. Well, these are both to the first power, so this is just going to be x. So 18x is going to be the LCD. Okay, one of each factor, you have x, you only need to write it once. Okay, now multiply each fraction by what's missing from the LCD. So you want to make 6x and 9x into 18x. So to make 6x into 18x, we're going to multiply by 3. It already has the x, so we don't need to multiply by an x. And then to make 9x into 18x, we're going to multiply by 2. So on the top, we have 3 times 4, which would be 12. 3 times 6x would give us 18x. 1 times 2 would be 2. 9x times 2, 18x. Okay, then we add or subtract across the numerator, so 12 plus 2 is 14. We write it over the common denominator, 18x. Now this one we don't factor, but if we had factorable problems, then we would factor and then simplify. Now this one we can simplify. We can reduce both of these by 2. And that would give us 7 over 9x for our answer there. No, not always. Depends on what the problem is. So then when you look at example 2, it gets a bit more complicated, but we just start following the steps. Okay, so we have subtraction. So I'm just going to distribute this. There's only one term, so just make it a minus 7 there. All right, find the LCD. Now remember, to find the LCD, you got to factor. So first, we need to factor. Then we find the LCD. Okay, so y squared plus 6y plus 5, what can that factor to? Y plus 5, yeah. Y plus 1. And then y squared minus 1, what can that factor to? Remember, 1 is a perfect square. That's y plus 1, y minus 1. So then the LCD you want in factored form, one of each factor. So you need a y plus 5. You need a y plus 1. You already have a y plus 1. You don't need to write it twice unless it was squared. It's not squared. Y minus 1. Okay, so one of each factor. All right, step 3. We're going to multiply the top and the bottom by what's missing from the LCD. So the first fraction, missing a y minus 1. So we have to multiply both the top and the bottom by y minus 1. Second fraction is missing a y plus 5. So top and the bottom gets a y plus 5. Now on the bottom, you do not have to multiply that out. Okay, you'll leave that in factored form. But on the top, you do have to multiply that out. Okay, so you're going to multiply out on the top. Okay, meaning you're going to do y minus 1 times y plus 4. So that's going to give us a y squared plus 4y minus y minus 4. Then we'll also distribute this negative 7. Negative 7 times y, negative 7y. Negative 7 times 5, negative 35. So we multiply that out, and then we're going to add or subtract across. So now I'm just going to combine all these like terms in one line. So I bring down a y squared. I've got 4y minus y minus 7y. So 4 minus 1 is 3 minus 7, that should be a negative 4y. And then negative 4 minus 35 is negative 39. I'm going to write this over my denominators, y plus 5, y plus 1, y minus 1. Okay, now, if I can factor my numerator, I will. Let's see. 39, you have 1 and 39, or 3 and 13, I believe. Yeah. Those are the only things that go into that. Any combination that would give you 4? No, you could get a 9 with this, but that won't factor. So we're going to stop there. If we could factor, we factor, keep going. So this is done. You're going to leave the new denominator in factored form. Yes. I mean, you just have to go through kind of what I did here to see if you can factor. So I'm looking at the 39, and I just write down everything that multiplies the 39, and then I look for a combination to see if it gets, it could get us to a -4. Yeah, it's with numbers, the least common denominator is the least common multiple. Yeah. Okay, so let's take a look at this problem, which is combining subtraction and division. So you can't divide until you do the subtraction first because the subtraction is in a parentheses. So we're going to want to do this subtraction first. So I'm just going to bring this out over here. Okay, so nothing to factor. It is subtraction, so I'm just going to go ahead and take this negative, put it next to the x, make it positive. What would the LCD here be? Very good. X plus 1, x minus 1. Just one of each factor. Which means then I'm going to multiply each of these fractions by what they're missing. So this one is missing an x minus 1. And the second fraction is missing an x plus 1. Okay, then I'm going to multiply out across the top. So I have x minus 1 times x is going to give me x squared minus x. And then I have a negative x times x, negative x squared minus x. I'm going to combine these like terms. X squared minus x squared cancels out. I have negative x minus x. That's going to give me a negative 2x. And that's all I have for my numerator. So then I'm going to write it over my LCD, which is x plus 1, x minus 1. Okay, so my grouping, my parentheses, is simplified, so that's subtracted. Now I'm going to divide by x over 5x plus 5. Oh, no parentheses there. Okay, can I factor anything in the second fraction? Yes, I can. I can make this 5x plus 5. I can pull a 5 out and get x plus 1. Okay, then I do my division, which is I'm going to keep the first fraction as negative 2x over x plus 1, x minus 1. I'm going to change the division to multiplication. And I'm going to flip this fraction into 5 times x plus 1 over x. Okay, then make this one long line, and let's cancel out what we can. What can we cancel out? X plus 1s. So I can take the negative 2 and the 5 and multiply them. But what about these x's? They're singular x's, right? Those are fine. Those cancel out. X divided by x is just 1. Now I can take the negative 2 and 5 and multiply, and get me negative 10 over x minus 1, and that's it. You could put the negative in front of the, like, in the middle if you want, yeah. All right, example 4. So subtraction, which means you need to take this minus sign, distribute it first. So this is going to be a minus x minus 3, plus sign there. Okay, let's factor x squared plus 8x plus 15. Yep, x plus 5, x minus 3. What about x squared minus 25? Plus 5 and minus 5, good. So my LCD, one of each, x plus 5, x minus 3, x minus 5. Yes. X plus 3. Plus 3. Good catch. All right, multiply each fraction by what's missing. So the first fraction is missing x minus 5. And the second fraction is missing x plus 3. Next step, we will multiply out the numerators. So I'm going to distribute this 12. 12 times x is going to give me a 12x. 12 times negative 5, negative 60. Then this I've got a FOIL. Remember, this is negative x minus 3. This is negative x times x will give me a negative x squared. Negative x times 3, negative 3x. Negative 3 times x, negative 3x. And then negative 3 times positive 3, negative 9. Okay, now I'm going to combine the like terms across the top. So I've got the negative x squared by itself. I've got 12x minus 3x minus 3x. That should give me a positive 6x. And then I have negative 60 minus 9, negative 69. All right. Then we'll put that over the common denominator. X plus 5, x plus 3, x minus 5. And now we will see if we can factor. So I think that we can pull a negative 1, at least, out of here. So negative 1, which would give me a positive x squared minus 6x plus 69. If I want to factor 69, I'm going to think, okay, you've got 1 in 69, that's not going to combine to 6. 2 isn't going to go in. 3 will go in 23 times. Anything else go into 69? 4 doesn't go in, 5 doesn't go in, 6? No. 7, no. Nope. I thought that one I would be able to make a little bit smaller, but I did not. So yeah, those are the only things that multiply to 69, and neither of those would combine to 6. So that's it. You could really leave the problem like this, then, I guess. This would be equivalent. Pulling a negative 1 out doesn't really do I'm sorry, what was that? Yes. Yeah. Yeah, these are the same thing. I'm guessing on the homework, the first one is probably, if you had one like that, probably going to go that way. If it comes out to be one that like you can't factor, just leave it like that. Pulling the negative one out might mess it up. But they are equivalent, so if you put that on a test, I would be fine with that. Mm-hmm. So, right, are you multiplying by negative x minus 3 in the top? So you want to, no, you wanted the very first step, distribute the negative sign. Because this was plus, well, or no, it was minus x plus 3. So you distribute that, that gave you the negative x minus 3. Okay, let me see here. I think I can give you guys one to practice. Yeah, let's do one to practice before we do this. I'm trying to find one that like comes out nice and concise, but it looks like a lot of them don't. Maybe this one. All right, so you got 10 over x minus 9 plus x minus 189 over x squared minus 81. Okay, try that one. Okay, so we can factor the second equation. What can we factor? Yeah, denominator is going to be x plus 9, x minus 9. What is our LCD here? Good. All right, then we will multiply each fraction by what's missing. So this one is missing x plus 9. This is not missing anything. So we don't need to multiply by anything. So then we will do the numerators. So we have x times 10 will give us a 10x. 9 times 10 will give us 90. And then we'll bring this over, plus x minus 189. We combine all of that. That will give us what? So 11x minus what? 99. Ah, can I factor that? What can I pull out of that? So that'll give us 11, and then x minus 9. And then we'll put that over the GCF, or sorry, not GCF, LCD. Get my acronyms here. And then we can cross out our x minus 9s. So then our answer there is 11 over x plus 9.